Hi everyone, thanks for joining us for the Testing Food Delivery App LinkedIn Live. I'll just start by presenting myself. I'm Ido. I'm one of the co-founders of Loadmill. My background is I started my career as a QA engineer and switched later into software development. I've been later been an engineering manager in a startup and later in a large corporate. And I co-founded Loadmill. What we do is we basically do deviceless mobile testing. And a lot of the things we do are sort of like based on the challenges that I had as an engineering manager when I working on very similar products. And I do some reverse engineering of apps for fun and post it online. So maybe you've seen one of my videos before. Today we're talking about testing food delivery apps, and I thought that there are some unique aspects that are worth mentioning and some unique challenges for these apps. So let's dive right to it. So actually, the typical food delivery app and obviously there are many different types and many differences between them, but the typical food delivery app is usually not just one app, right? Usually, what we see on the surface is the customer app, basically where you order your food, you track your orders. There's some aspects of personalization and obviously paying for your orders. These are usually are combined web and mobile apps. So many companies also have like web interface if you want to order, and the mobile interface also to order. And then once you order you submit your order, usually it goes through the store app, which is usually a different app. I call it the store, but you can think about it as a restaurant. And this is where your order will be received and someone will actually have to prepare it, right? And usually these apps are slightly different. They're like, usually they're either sort of like a point of sale or a desktop app that are installed on like dedicated desktops, or sometimes in the more modern one, these are like usually tablets, and then they're just like regular apps, and they're tablet apps, mobile apps, and they use them to accept your orders and reject them, manage, track them, everything you would imagine. Once your order is ready, it usually goes to the courier app, which is usually a different app. There are some apps that are, very unique. They have sort of like the partner model. Yeah, you can think about like with Uber, right, where people partner with Uber to drive you around. So there are apps that have the courier as a partner, and this is also a very different app, right? The courier usually they're in standby mode, and then they receive an order. They go to a specific store, they pick up your order. Everything that happens in between, right? You need to track their status. You need to track their location. You need to notify the customer app while the courier is on the way, and also instruct the courier usually through navigation, stuff like that. So usually food delivery apps are more complex than just one app, right? You have like different apps installed on different devices, mobile, web, desktop. Everything is sort of like combined together. And what do all of these apps have in common? They all use APIs, right? So basically, all of them communicate basically with this centralized backend, right? You need your mobile app, your ordering app, to send the message to the restaurant, and then you need to turn it to the carrier. But everything talks through API. These apps usually have some specific challenges that we came across while working with different companies. So I'll just obviously there are many different challenges, and challenges very general, like testing challenges, like setting up the testing environment and all that, or mobile testing challenges. But there's challenges that are specific to food delivery app that we ran across, and I just want to mention some of them and the ways to tackle them. In the end, I will also show a demo of some of these tactics. So let's go through these challenges. I broke it down. So the first challenge that is pretty obvious, they're cross-device flows. So imagine you want to set up a test that starts from the web, a customer order, creating the order. Then it goes on through the point of sale app, right? And you need to handle sort of like a continuum of this scenario in the point of sale app. And then you want to also transmit that to the courier app, right? Which are completely different apps. If you're thinking about end-to-end UI testing, the way to do it will be each one of these steps will use like a completely different technology, it's very challenging. And this is why I think a really good fit here is to look back at the testing pyramid and think how we can do it. Since all of these apps use APIs, I think the best strategy here for these cross-platform asynchronous scenarios is basically looking at API testing, right? If all these apps talk with one another through APIs and you want to set up this end-to-end cross-device test, the best fit here is API testing, right? You can use the basic customer API, right, and create the order. Then you can track it back into the store API and do a lot of stuff right around that. And API testing is a really good approach. So if you want to, obviously we'll still need to have UI testing that for each dedicated app separately, right? But you can test that, independently from the backend, right? You don't have to use the backend for that. And you'll have like a very solid UI coverage. It will basically cover the UI aspects of these apps. And then we'll have the end-to-end scenario built through the API. So I think this is, very good ROI in this suggestion. This is a very good strategy. Another common challenge that we see, many of these apps, usually I'm talking about the customer apps, involve email and SMS verification, right? Some of these apps, because for some of these companies, there's also no website, right? It's just a mobile app, or it's very, very centric, built around the mobile app. SMS and email verification is basically, some of them even don't have like a password login, right? You only logged in through like an SMS or email verification. And this is quite challenging when you do test automation, right? You need to sort of like work around that. The solution that I see works best here is using something called an ephemeral inbox, right? Basically, it's an inbox dedicated for testing that has a dedicated API that you can access the emails that were sent to it. And basically, you register your user with this ephemeral inbox email, something like that. You can do the same with text messages with services like Twilio. I will show that later. We also have an internal support for that in the product, where you can send these emails, capture them through APIs, and basically use the data that was sent in the email in the following steps. So you can basically do the registration with one of these emails in using these ephemeral inboxes, and basically you can capture the verification code that will be sent to you during the registration process. And then you can basically extract that ID using a dedicated API, and basically use this code in one of the following steps to log in. So this is it can be sometimes pretty tricky, but with the right tools, it becomes a pretty simple problem. Another thing that we come across pretty commonly in food ordering apps is live tracking. This has become the standard in the recent years, that the customers expect to know exactly when the food is coming, right? So a lot of these apps combine these live tracking components, where basically after your order, you can track your order, you can track like exactly what the courier is right now. And there's some knowledge to it, right? You need to, when you write tests based on that, you need to do some geolocation calculations, right? Some of the data that we will get through the API is coordinates. You need to be familiar with how lat-long coordinates work. Maybe you want to do some calculations, I don't know, about the distance and stuff like that. So these are some techniques that you will probably want to be familiar with. Also, the aspect of like actually getting the data for the current status. There are two main methods, and the older one was basically like HTTP polling. So you had the mobile app basically firing HTTP requests again and again, polling for the status of the order and getting all the recent information. This is something that you should probably take into account when you write these tests, right? You want to wait and poll for the latest information about the current status of the order. But the more modern apps, and actually all the ones that you will see that were launched recently, are using WebSockets, right? So instead of polling for the live status every time, they use bidirectional communication, where you can basically get the message through WebSockets from the server every time there's an update. You don't need to call it for this information. So WebSockets also becomes a pretty important component when you talk about testing food delivery apps, and it's important that you have that ability to test using WebSockets in your toolkit. Another common challenge that you see, it also comes up in different apps, but it's very dominant when you're talking about food ordering apps, is billing and payment, right? I mean, this is basically, you can't end any scenario usually without actually using some payment mechanism, right? Because every order includes payment, every restaurant needs to accept that, and every customer needs to submit the payment, right? And something here is super important to know. Most of the payment vendors that you will work with, so if you think about Stripe or other credit card processing vendors, usually have dedicated test environments and dedicated cards involved. So if you're familiar with that, I mean, usually this number is my go-to number when I'm talking about test cards. This 4242 number is just a dedicated testing card that you can use in your app. You need that your app will be connected, your testing app will be connected to the test environments with the relevant vendors. So for example, if you're using Stripe, you need to use their test API and not their production API. Otherwise, they won't be able to process this card. Another thing that's important to be aware of is we don't only do testing in testing environment, right? Sometimes we also do some sort of acceptance testing in production. And you need to be very sensitive when you do that around billing and payment, right? There are no really good solutions for that, except of using a dedicated company card, basically to do these tests. You have to be sensitive about that because usually that's an actual credit card, right? You don't want to lose it, and you need to store it somehow safely. So you might think about like rolling these cards now and then, but there are no really good solution here, because if you want to have all of your end-to-end tests also be able to run them in production, you have to do some work with actual credit cards. And this is somewhat of a sensitive point, but I'm not familiar with the really good solution that works around that. So it's sort of a gap that if you want to include like actual charging in your tests, you'll have to work with that. So as I mentioned, this is basically how Loadmill can help you with doing that. We have this deviceless API testing approach where you basically we can capture scenarios from your mobile app, from your point of sales app, from the tablets, from desktop, from web, anything. And we basically capture the API traffic that goes through these apps to the backend, right? We capture these API calls, we feed them into the Loadmill algorithm, which basically generates the automated test code for you. It's a very simple process. We can show that right now with one of the food ordering apps. But I think it's a really, really solid strategy to mitigate all these challenges, right? So if you think about these cross devices scenarios, these are very, very hard to do if you think through UI testing perspective, right? If you do Appium, if you do, if you do Selenium, it's really hard to combine these tests together. It creates a big challenge. So I think the API-driven approach is a really good fit here. And there are many benefits for that. First, API testing is super fast, right? So besides being able to mitigate all the other challenges that food ordering app testing has, these tests are super fast. They're very stable. They don't suffer from the flakiness that is very common with UI testing app. I think it is like the most efficient way to test this app, right? Because it saves you a lot of the hassle that's involved with setting up all the mobile devices. Even if you're using virtual one, there's some setup involved, reinstalling new versions of your app every time. It's quite challenging. So it's extremely fast, it's very stable, and it's a very efficient way to test your app. Obviously, you will still need some testing done around the UI layer itself, but it minimizes that into the bare minimum necessary, and it's I think the most efficient way to go about it. So now I'll just show a few of the things I mentioned, and let's poke around and do some demo. I'll start my scenario actually kind of like I imagine someone recording, creating an order through the web, right? So for that, we have the web recorder. This is Wolt. It's a very popular Israeli, it's not Israeli, it's a very popular European ordering app. It's the most popular one in Israel. And here we have the Loadmill web recorder, which can basically capture all the APIs that will be sent while playing this scenario. And let's see how it works. So I basically start capturing, and let's create my order. Let's order a burger or something. And you can see all the APIs that are being registered while play this scenario, right? And let's create a group order or something like that. Since I'm actually testing in production, I won't go and finalize the order and put my credit card and everything like that. We'll just stop just a step before that. But you can see all the APIs are being registered here. I created an order group. I can also delete it. And once I feel good about the scenario that I created, let's look at the APIs that were created, right? So this captured all the APIs that were involved while playing this scenario. The first step is usually analyzing these requests. So what Loadmill will do now is basically use kind of like ChatGPT. We use the Codex engine, which is also the same algorithm that behind ChatGPT. And we'll basically create descriptions for all the steps that happens in these tests. And we'll also try to strike out some of the requests that are not relevant. So it looks good to me. Some of the requests were decided by the algorithm that they're not relevant, but some of them are still considered relevant. One interesting thing is to see that this recorded scenario still includes some hard-coded IDs, right? These IDs needs to be parameterized if I want to actually run this test again and again. So if the test request, the selected request looks good to me, I can click Create Test and actually go send this information to Loadmill, and we will generate the testing code for you. And we'll do it live while we're looking at. So it takes about like 45 seconds to create the test, but we'll actually go and write the test code for this scenario in Loadmill. Okay, so this is the test that was actually generated right now. It's actually, sorry about that. This is the test that was actually created right now. You can see that we did some work with it, right? So we parameterized a lot of the requests. We extracted some elements into parameters. For example, we extracted the base URL into a parameter because maybe I recorded it in the production environment, but I want to actually run it in the test environment. So we can rename this URL into something else. And we also did a lot of other processing, right? So for example, this delete group order request, it used to use an actual hard-coded ID. We automatically extracted that into a parameter, and we automatically extract this parameter from the request to create this group order ID. So this is how I will go recording a scenario from the web. Basically, I mean, once the scenario is ready, I can basically run it. I can debug it from here and see that it works okay for me. If I'll run it right now, we'll probably create an order and delete it in Vault. And I can drill down and see, you know, all the relevant information. This was the request that I to create the order group, and this is the actual ID of the order group that was created. We automatically extract it from the response, and we automatically use it in the request to delete the group, so it passes successfully. So we do all the wiring automatically for you. Now we can basically do the same for a mobile app. So I don't actually have an access to the restaurant version of DoorDash, but let's look at the mobile ordinary DoorDash app. Basically, the setup I have here is I have an Android emulator, and I can basically play around and poke around this app. I can play a scenario. If that was the courier app, I could basically accept an order and you know, and do something with it and accept it and just like simulate a courier picking up an order or something like that. And while I do that, I use an HTTP proxy. You can use any HTTP proxy that works for you. I'm using Proxyman, which is really cool, has a really cool free version. We also at Loadmill, we have our own HTTP proxy. There are many good ones. I mean, there's Charles Proxy, Fiddler, Wireshark. You can basically use anything. So then I can capture all the API calls that are, invoked when I play this scenario, and I can save it into a file and upload it to Loadmill. So it's, or if you're using the Loadmill recorder, you can do it by one click, right? And once I upload this scenario into Loadmill, it will also generate, here it's set up to generate the descriptions for the request. So you get a pretty long scenario, but it basically plays everything that happens while I played it through the mobile app, right? You get all the API calls here. You can see this one gets the number of the item in the cart, and you get a lot of logic. This is where I add some items in the cart, and you can basically play around with your app, and Loadmill will write the code that basically simulate these scenarios for you, right? So it's very cool, and you combine these apps, these elements together. So for example, I can create one test suite where I have one test that actually like creates the order, right? And then I can switch on to the point of sale perspective and do like some API calls that actually accept the order from the perspective of the restaurant. And then I can use like the Wolt partner app, and I can accept the order and I can mark it as delivered. So I can do these sort of like multi-cross device scenarios and get really solid coverage for all of my core logic pretty simply, right? I just need to play this scenario through this app, capture them, and sort of like bunch them together into one test suite. So, I mean, this is how we usually go about it. There are some cool resources that we can share if you want some explanation of how to work with ephemeral emails, because it's basically just a good example, but it's very similar for text message and SMS messages. So basically, we have a guide here. Maybe I'll post it in the comments later. Just for example, I shared here the Stripe example. They have a very detailed documentation for the testing environments. It's a dedicated API with different URL. You have like the list of all the test cards that you want to simulate here, right? So you have your Visa card, your MasterCard. It's very detailed if you want to work with payment methods in the test environment. And yeah.